Uh, I think Panirai sir, has he joined?
नहीं पानी सर जेवण करना होता
भेटी तुझी याचे टेचा तू
Sir, join kale ki amar Panirai babu, or we start the meeting?
नहीं पानी जेवण करना होती
Okay. Now it is 6:34 alani. I think we'll start the meeting. I think we'll start, sir. Dr. Mishra, ଆପଣ ready ଅଛନ୍ତି? ଆଚ୍ଛା. So good evening to all. I welcome all the esteemed participants for this invited special talk by Dr. Manoranjan Mishra. This particular talk is specially organized after knowing from different quarters about the contribution made by Dr. Manoranjan Mishra in the field of his own subject, geography, as well as climate and lightning and many other aspects of climate. And before I hand over to Dr. Mohanty, I would also welcome once again our very respected Professor K.C. Sau from former Bombay IIT and other distinguished participants. So we have also with us our Vice President, Mr. Tilochan Mahanta, and all our esteemed members. So I would request now to our Dr. Manoranjan Mohanty to introduce the speaker and take over the proceeding from here on. Dr. Manoranjan Mohanty.
Thank you, Yendra sir, and good evening to all the respected attendants who are showing interest for the very good relevant topic today, which will be delivered by Professor Manoranjan Mishra. Before going for the introduction of Professor Mishra, just take small incident I want to highlight that about 25 years before, probably 2002, when M. Rajendran Sir was the governor of Odisha, Geological Survey of India got a very interesting letter from one erudite IS officer, Nilanjan Sanyal, that you see that lightning is becoming a real killing factor in Odisha, especially coastal Odisha, and whether Geological Survey of India have any program to either to predictability of the earthquakes or eradication, or it can be whether what can be done about it, since it is remotely related to a natural disaster and all these things. Since then this particular thing was biting to me, that really it is a uncontrollable sort of a natural disaster, and very little work is being done. IMD is doing, but for the predictability of these particular incidents like that of your earthquake situations, I didn't get much of work has been done in Odisha and all. All in a sudden, sort of a in a seminar, we came across Professor Manoranjan Mishra, who gave a beautiful lecture about this particular aspect of this life. And so it's a real concern for not only for the administrators, but also for the geoscience community. That was the point that I met Professor Mishra. Now regarding, and I was having a mind that I will not let any incident or any event when I can get a chance to call Professor Mishra, and he readily agreed to that. Thank you, Professor Mishra, for that. Regarding Professor Mishra, uh, he is absolutely a right man for this type of job, in the sense that he did his BSc from Ravenshaw University, Ravenshaw College, keeping chemistry, geography, and geology. He was having a geology, so he understands both earth science as well as geography, and it is actually a befitting subject for him. And then he did his MSc in geography from Ravenshaw University, completed his MPhil and PhD from Jawaharlal University in Delhi, and he was a recipient of the JRF in geography as well as in earth, atmospheric, and ocean sciences, reflecting his strong interdisciplinary academic excellence. That was the point actually. Then his research integrates geography, climate science, hydrology, remote sensing, GIS, artificial intelligence, and disaster risk reduction, with significant contribution in the fields of lightning safety, coastal hydrodynamics, sea level rise, agricultural drought, forest fires, climatic resilience, and sustainable development. Through his innovative research and policy oriented work, he has been actively contributing to climatic risk assessment, early warning systems, and evidence based environmental management of regional, national, and international levels. Dr. Mishra is a professor in the Department of Geography in Fakir University since 2022. Between 2010 and 22, he was associated with several reputed institutions like Sikkim Central University, University Putra, Malaysia, Gangadhar Meher University, Kalikot, Gangadhar Meher University, Kalikot University, Barampur University, and also served as a visiting professor of the ISAR Barampur. Professor Mishra's research expertise lies at the intersection of geospatial technologies and natural resource management, with a particular focus on understanding the impacts of extreme events in coastal and environmental systems. His work has significantly contributed to advancing knowledge on climate-induced hazards, coastal vulnerability, and risk assessment. As of 2026, according to Google Scholar, Professor Mishra has authored 106 science citations in index research papers with cumulative journal impact factor of 445. His publication has received over 3,343 citations, with an H index of 33 and I-10 index of 78 as per Google Scholar. Additionally, the Scopus database reports 2307 citations and an H index of 257. Dr. Mishra has successfully handled 5 major research projects and 6 international consultancy assignments, and has delivered numerous invited lectures and keynote talks in India and abroad. Currently, he is leading 4 ongoing research projects funded by NICS, NRSC, NRF, PAIR, and ISRO, Respond, and IRO, reflecting his continued engagement in high-impact policy-relevant research. Recently, he has been taken as one among the three sort of a that world this thing that 5% of the world scientists his name has appeared in that, and FM University feels proud about that Professor Manoranjan Mishra is associated with FM University as professor and head of geography department. So I now request Professor Manoranjan Mishra to initiate his talk. You can share your welcome, Mr. Sir, and you can share your, yes, it has been shared, yes. Thank you.
So thank you, sir, for a brief introduction. So am I audible and my slide is visible?
Yes, you are audible. You can continue now.
So a very good evening to everyone. So thank you, the Society of Geoscientists and Allied Technology, giving me a chance to present my work, or which I have done in last maybe 2 decades. Specifically, coming back to Odisha, so working in mostly on geospatial technology and machine learning kind of things. So my title is like Future Soft to Future Ready, Navigating Climate Uncertainties in Odisha. So I start my presentation with a quotation from Albert Einstein, that time and space are not condition of existence. Time and space is model for thinking, which is very relevant in 21st century. When we talk about 21st century, it is full of uncertainties that may be climate induced or maybe anthropogenic induced. The next generation will be facing a lot of uncertainties, and I don't require to put my discourse that climate change is happening or climate change is the reality. But some of the data of the NASA is showing that the Earth is becoming hotter. But the problem is there is, apart from climate change, which is a very natural process which has happened in a geological past, so that 5 mass extinction has happened. We are in the early stage of 6 mass extinction. But another factor is growing human pressure, and obviously there will be decline in ecosystem and many surprises will be coming up. So understanding these surprises or uncertainties and adapting with this system is the only way we can go ahead. And means most of my work which I will be showing, as sir has already told about lightning, I will be showing a more climate induced extreme events. So whatever research I have done, I just put like small change in average, uh, big change in extreme. That means I just want to put like this, like if there is an increase in 1 degree in maximum temperature, so what will happen to the atmosphere? 7 to 14% moisture holding capacity will be increasing in the atmosphere in that particular region. Then if that much of moisture is available, so what will happen? Next, obviously, it will be dispersed in form of extreme events. That may be lightning, or if moisture is not available, it may be heat waves, or it can also translate if we are seeing the things which are, you can say, new normal, like tornadoes, or maybe a lot of activities happening in the transition phase also, we are seeing the atmospheric floods and intensification of cyclone. These are mostly related to temperature and moisture. So coming to why Odisha is at a climate crossroads. So this is a research work which we have communicated just in ESEB journal. So I am just showing the result, but it is not published yet. Odisha is like a disaster capital of India, or our geographical location is so that a lot of things are happening. And the major finding what we observed, looking at ERA 5 data, IMD data also. And we have done some projection using CMIP6, where we have seen statistically significant warming, that is 0.015 to 0.01 degree centigrade per year. And there is a erratic rainfall also. And the major problem is significant stagnation or decreasing tendency of soil moisture after 2018 and 19. So what our result shows, but there are many uncertainties in this result because we are using the IMD grid data of 100 years. So it all depends on what observation they are doing. Then there is a future projection of 1.5 to 2.2 degree centigrade increase. So what we targeted, like government of Odisha or government of India is targeting 2036 and 2047. So that is why we try to understand. So a lot of things will be happening. So these are all scenario models. So there is a urgent need for multivariate assessment to sustain at least agricultural production under climate change. So a lot of research has to be done. Then apart from that, in the you can see there is a table down, which is a paper which is published in Current Science. So what we did, we tried to see the climate-induced natural disaster deaths. So we took it from NCRB, and I think there is some kind of disturbance. Okay. Then what we did, if you can see here the data which we have taken in for Orissa, if you see 70% deaths are lightning. The second one is heat wave. As I said, if there is the increase in 1 degree maximum temperature, obviously we have 480 means like 500 something kilometers coastline, and a huge bay, means you can get moistures from these Bay of Bengal. So obviously, so it will be transgressed to the land, and then a lot of meteorological events will happen. And what the data is showing, like the cyclone death has reduced, but the lightning death has increased. You can see the reason is why, if you see, there is more death in lightning, but compared to less death in heat waves. The reason may be, we can say, the recording in case of lightning is more accurate, because a compensation is given. If anybody who dies due to lightning, the body goes through postmortem and they are being reported in SRC. But in case of heat wave, so no such recording is being done. So that may be the reason. If you see 91% death, which is is either due to lightning or heat wave. I just want to explain here what is my observation. As I said, if you go to the pre-monsoon, then we'll go to monsoon and post-monsoon. If you see in the pre-monsoon, so there is a change in sea breeze and land breeze. So if like it is the central India starts heating up, so what will happen? So heat wave condition created, and what will happen? It will not allow the moisture means to come to the land. So obviously, then the heat wave condition will be there. So whenever there is a weak heat wave condition, so because as it is already heated, so if the moisture is coming from the Bay of Bengal, so more high intensity lightning activity. So Odisha will be facing these two things, lightning or heat wave, maybe in alternative year. Like this year, we are discussing about El Nino and a lot of things. But still, this is a reality and we have to face it. And talking about seasonal disaster calendar of Odisha, if you can see, because as a researcher, we look into every 7 days or every month, what exactly is happening. In pre-monsoon, you will have heat wave, lightning, hailstorm, tornado, forest fire. In monsoon, you will have flood, flash flood. What we are talking about, atmospheric floods, a landslide, extreme rainfall. Then we have post-monsoon cyclones, storm surge, or heavy rainfall. In winter, we'll have cold stress or drought persistence. So that will affect each and every sector of the economy or our livelihood, maybe health risk. There are a lot of damages, and like as a researcher, we are trying to highlight all these issues, and we have to adapt with this system. If we don't adapt, so there will be losses, and we have to plan, obviously, from today only, if you are thinking about 2036 or 2047. So then I just will go about whatever methodology I have used in doing this research. Like in geography, we say cartography, the art of map making, but traditional cartography was static, paper-based, descriptive. Even if geology or anybody from our science, so we work with location. That is where. Then we talk about what is the characteristics. Then we talk about what next. That is the predictions we used to do. For that, you require a lot of data. Then you translate into information, knowledge, or wisdom. So current geospatial era, like dynamic, real-time, predictive, we are doing, but still means a lot of things are coming up which are open source. Like if anybody is a young researcher, you don't require a lot of investment to this do this kind of research, because many of the data are either open source or model data, or open source softwares are there. Many things have been developed, like satellite, drone, sensor, then machine learning, web GIS. A lot of things are coming up. So talking about climate crisis, so we require geospatial AI or geospatial intelligence, because we require something which can, if you ask a question, it can give you an answer to the decision maker or the policy maker. So that is why there is a demand for geo AI in whatever field related to the art systems. Then this is an explosion of geospatial data. So basically, I have already talked that mostly we work with geospatial technology, that satellite, drone, Internet of Things, which is a very new thing which is coming up, citizen science, massive increase in spatial resolution and temporal frequency. Challenge is turning data into meaningful insight. So as a researcher, my job is, like when I talk about data, which is very raw in format, if I add a meaning, it becomes information. So if I put a rule and regulation, it becomes knowledge. So mostly we means like our economy will be knowledge-based economy, and as an art scientist, our job is to convert this knowledge into wisdom also. And this kind of knowledge has to be translated to the society. If not, like what I say, last mile connectivity. If not, then like whatever death is happening due to the extreme event, it will happen, because we are the group of people who should understand means what exactly is happening, how to get rid of it. And I can say, like, very simple behavioral changes can save life, rather than lot of forecasting. Obviously we are doing, I will be highlighting during my lightning slides. This is a whole about, I think many of you must be knowing about geospatial technology. It is surveying, scanning, GNSS, Earth observation, GIS, and spatial analytics. When you talk about these technology, and mostly people think that either it should be IIT or a central university you can do, but right now, so there are a lot of changes has happened with the data, which is open source. There are a lot of platforms which are coming up, like cloud computing platforms, like Google Earth Engine. There are a lot of millions of model data are available. You can just work with them. So a lot of opportunities are there. Means working at a local region, or means you can also work at the national level also. So these are the data set. If anybody means, obviously we are using. That is, if you are talking about temperature, rainfall. So IMD has a gridded data which is pretty level. Then there are a lot of satellite data are there, model data, chips. Then ERA 5, if anybody is working with reanalysis or any models, or you are working with a forecasting kind of thing, you can work with ERA 5. Obviously, there is a lot of limitation also when you talk about accuracy and error. There are a lot of things, but we can fix it. As somebody who works at the local level can fix a lot of errors, because we have to move from the model to machine learning. That is where machine learning can play a very critical role. Then there is Sentinel satellites. There are very high resolution, data are available. but still there are a lot of limitations which we have to highlight. Then talking about, these are the platforms like Google Earth Engine, then open source softwares are there. A lot of softwares are there which are freely available, like university, like Fakir University or a state public university doesn't require fund to invest on that. Rather than to train scholars how to work with these kind of skills. So it's better not to invest on these things. Only you require internet and some kind of minimum end computing platforms. That you don't require high end computing platforms, but sometimes you require. But again, you can collaborate. You can get access to these high end computing. Then this is the geospatial intelligence, because the future generation which will be looking that, as I said, shift from what is where, why, so what, and what next. Like we require to integrate AI. So when we talk about artificial intelligence, like we think that it's a computing kind of thing, or somebody from computer science has to do. It's not like that. Like learning Python and working with n number of data. Then there is a cloud computing platform, so which is the need of state public university where fund is a crunch. A lot of mobile platforms. Then you should know the art and craft of visualization or geo visualization kind of things. Then there is one thing I think, as a art scientist or a geographer or a geologist, what I assume there is something which is coming up is called a geodesign. We have to think like nature. What I believe that like the art system which was formed in 4.6 billion a year, somebody is doing some test or experiments. Some design is being working, and we have to understand what is the threshold, and where is the safe and unsafe areas where means you can work, or something you can do when you talk about climate change. Then this is I will be talking about, sir was talking about lightning. Obviously, as I have already told about Odisha, but what is the trend of lightning fatality in India? We have a publication which we have highlighted that 1,13,9 people have died from 1967 till 2020. Means on an average, if you see in the last 2 decades, means if you see, it was 1,800 death in India, but it has increased to 2,800 to 3,500. And in case of Orissa, every year like 287 death is happening. And if you compare with the USA, the death is only 20. And whole Europe, the death is 80. And China, it is 300. And if you ask me, like Balasore, only 20 to 30 deaths is happening in Balasore, and in Mohan almost 50 deaths is happening. So that this a particular research I started while I was working as associate professor in Berhampur University in natural resource management and geoinformatics department. Basically, one student was killed. So that's where our research started from 2022. Means maybe a month after I was shifted to Fakir University. I will just say a very simple thing. Like I am giving 4 case studies, and let us say I know many of you are very senior and you have more experience than me. I just put forward a very simple question. Like there are 4 case studies. First case study is like a farmer family at 2 o'clock in Moirganj, Rairangpur, where the Prime Minister and President is visiting. So they were working at inside the agricultural field. Only 4 people were there. Means like a husband, wife, and 2 kids. So what happened? The rain started. Then the lightning also started. Then this family decided to go back home. So the 2 kids starts running. So when they started running, the wife started running behind them, and the husband was means wherever he was working, he was just putting whatever things were there so that he can take and go back home. Just I think it was only 10-meter difference, 10 to 15-meter difference between them. So lightning strike and the husband was killed, but the kids and the wife they were not affected. Then second one is like it was in Puri, a case study where a father, mother, and a kid of 22 years, they were working on a vegetable farm at 4 o'clock. Then what happened? Uh, the father and mother is seeing their kid, so the lightning strike to the son, and he just fall down. They were seeing in front of them. Then third was like my student case, in Barampur University, the exam they finished at 4 o'clock, the end semester exam in month of May, and these one boy and another girl went to the Gopal, that is close to Panthanivas. They were just sitting. So weather was very normal. It's changed suddenly, and a thunderstorm or lightning activity happened, and the boy was killed at that point and girl was critically injured. I just ask a very simple question to myself and everyone, that so what are the ways, like if I just ask you, if you go back 1 hour before, can we save all these lives? That's the question which I started research. So what are the ways we can save these lives? I mean, if I go 1 hour, maybe 3 hour, maybe 6 hour before, so if I see, so there is a way, means whatever death has happened, these are all avoidable deaths. We can save these deaths, possibly with a very simple, you can say, like from our past generation, like Stana, Kala, and Patra. So what we develop the model. But if you see what is the conventional way to reduce the death is like we are talking about forecasting. Mostly we think that can we give a forecasting before 1 hour, that is called nowcasting, maybe 6 hour forecasting, or maybe some 2-3 days before. But if I see the whatever forecasting is available for period of pre-monsoon, the accuracy is not more than 40 to 50%. Again, I will make you understand. So the death happens at a point, but the forecasting which is done is at a district level, and there are a lot of errors also there, and that is a limitation, you can say, means whatever models we are running or whatever data we are taking. And I will just give you some idea. I know most of you must be knowing that when there is an increase in temperature, so if moisture is available, so what will happen, the air becomes light, the parcel of air moves off, and when it moves off at certain height, so what will happen, so obviously the clouds start forming. Inside the cloud, maybe you can say there is the formation of ice particle and supercooled water. Like if you take the example of freeze, in the upper part you have different varieties of ice particle, like snowflakes, graupels, then ice particle. So what happened, they start colliding. Once they start colliding, what will happen, so charges will be formed. So positive and negative charge will be formed. So positive charge moves up and the electron or negative charge moves down. During that time period, anything on the surface of the earth induced as a positive charge, maybe anything. There is some kind of resistance also, but this is a very crude way to explain. So what will happen, so the lakhs of electrons will be coming down. So when it comes down, so what will happen, it will try to connect with a positive charge, and some conductivity will be created, so that they passes huge amount of electric current. And a typical lightning activity, 3000 lakh volt of electric current, a typical that can go up and down. And what I'm trying to say, in case of lightning, so there are two kinds of lightning activity happens. One is called as CC, cloud to cloud, another is called as cloud to ground. And in case of CC, like 85% of lightning activities are CC, cloud to cloud. It doesn't comes to the ground, so it is not dangerous. So only 10 to 15% comes to the ground. So it is also negative CG and positive CG. Negative CG, what we observed, that it connect with one feature, and mostly a single death happens. But in case of positive CG, maybe due to the pollution or aerosols available, so it becomes invert, and then it try to connect with 15, maybe many features, whatever is around. So there more death happen, and we are seeing in the mining areas. So there are positive sizes are increasing. What we are seeing from the observation data. Then this is, I think I have already explained, like charge separation, potential difference, steep ladder. So it will be like ladder kind of things. And then when this positive negative charge joins, so there will be flash. Then after that, you know that ground response returns to lightning flash. Then a huge amount of current will be going to the earth surface. But the problem is when it goes to the earth surface, the top layer of the earth surface will not allow to discharge this current. So it will move laterally. And obviously anybody close to that hitting point, living organism, maybe animals or human beings, they will be killed. So that is why it's so dangerous. Again, whenever we do a forecasting, the highest resolution is 12 kilometer, which is NCMRWA, and the ECMWRF 9 kilometer and 9 kilometer. But still, there is a lot of errors, or you can say false alarms are there inside the models. And whenever IMD gives a warning, so it gives at the district level. It doesn't goes to even into the block level many times. Then this is the impact of lightning. When lightning strikes, it strikes vertically, means it can enter your head, single entry, multiple exit, or it can enter your leg. If it is a lateral strike, then it can enter your leg. So like as compared to a human being, so the death of animals are twice. The reason is because they have a disadvantage. They have 4 legs and they are wide up. So whenever lightning strikes a tree, so 50 meters within anybody is there, so there is a chance it will enter your leg. If your leg is wide apart, it comes in circular way, equipotential zone. It can enter twice inside your body. And what it does, it will stop, like pumping of your heart. Then, so you will have a sudden heart attack and you will fall down. And in case of animal also, same things happen. And this is how powerful is lightning. I know you must be knowing. This is for my awareness campaign. You can see this is 3,000 lakh volt of electric current. So that's why it is a huge amount of current which is coming up. So what we try to understand, so what are the pattern of deaths which is happening to the human being specifically. So there is a direct strike. This pattern of death is very less in Odisha, maybe 1%, because it will enter your head and multiple exit. And it is possible when you become the highest point, or you became, means if you are standing close to a tree and you are close to the tree, means like there is a very small distance between you and the tree. So what will happen? Will be a potential difference and it will connect to your head or your soldier. Then this is the pre-monsoon time. Majority of death which happens in rural area, people stands below tree in Kalbaisari time. And if you see, many deaths happen. People either sleeping below the tree or playing below the tree. Some people are plucking mangoes or getting. Few days back, 2 people are died because there was a kalbaisaki or the mango fall down from the tree, and 2 people, they were just collecting this mango, and the lightning strike the tree and death happened. And what we see the data, like 96% of death happen in rural area, but only 4% death happen in urban area. This is our finding in case of Odisha. And in the pre-monsoon, the majority of death, if you see, in North Odisha, South Odisha, means mostly people stands below tree. And like we have done some sort of campaign in North Odisha as our university, like sphere of influence in Balasore, Bhadrak, and also Mayurbhanj. And if you see this year, the death has reduced. Means what we are saying, whenever there is a rainfall, either it is happening lightning or non-lightning, don't stand below. At least keep 50 meters away from the tree. So that only a simple message can save many lives. So lightning activity happens for 30 minutes to 3 hours. So we have to keep in these things in mind, and this simple message can save many lives. Then this is a ground current. So like as I said, so if it is hitting some tree, and it can enter water, or it can comes in the ground. And if you see, in case of Balasore and Mohan, and specifically in tribal regions, people having kacha houses. So death happen inside the house. So that's mostly ground current. If you have a tree in front of your home, it strike the tree, then it enter your home. So anybody who is standing on the ground can have a death. So that's called a step voltage. If you are walking during a lightning activity, so there is a chance that it can go inside, means it can come in the ground. So that is why during the lightning activity, try to be inside a semi-Faraday cage house. This is step voltage I was talking about. Many deaths happens in the farmland. Many times also people going with the vehicles like scooty, you can say two-wheelers, cycles, many deaths have. That mostly due to the ground current. And this is conduction, and any metallic, you can say materials. So if you are in contact with them, so there is a chance of conduction. We have seen many examples of deaths, like during lightning, someone like in a village. So the domestic animals are coming back to their home. So the gate was like metallic gate; it was open. So he thought that they will enter his premises. So he just went to close that gate. So lightning strike the gate, and he was killed at that spot. So that is why means during lightning activity, you should be away from the conductors. And this is torch voltage, and mostly these metallic structures. And in case of cars, or maybe your home also, which is a semi-Faraday case. When I say semi-Faraday case, means it's a metallic cover. What I say, if it's a car is a metallic cover, so if you are inside the car, you are safe. But if you are touching outside, so there is a chance of touch voltage. And in case of your building also, like there is a at the base you have iron and steel, which you have put 8 to 9 feet down. Then in pillar you have this thing metallic, that iron and steel. In the roof also metallic. So whenever this electron will come up, so the building, like in urban area, so what happens, either this building or the towers, they capture this and they discharge it. When we go down, maybe 5 meters below, there is no resistance. So that is why it can be easily discharged, and there will be no lateral movement. But if you go outside your building and you try to touch outside, then there is a chance of touch voltage kind of things. And then the water. And if I go to the 65% of the whole deaths happens from the month of June till August end. And these are all farmers, either farmers, laborers, grazers, or you can say construction workers. And we find many deaths inside the water. Water is a conductor, and in case of monsoon, the cloud is formed at the lower height, and it's very easy that electrons comes inside the water. So whoever is working inside water, so there is a chance of death. So these are the type. Another is called a streamer. Streamer lightning kill or injure when a person become conduit for an upward reaching electric. What I was talking about, positive discharge. Sometimes what will happen, the negative charge will be static, so it will not move down. It will try to pull the positive charge. When it is pulling, it can pull multiple pitchers. So there is a chance of streamer. Even if there is no pitchers, you are connected. So that is why these are very dangerous things. And in a single day, you find at a particular place in Balasore, one day 11 people died in single place. So that was not a negative CG, that was a positive CG. Then I'll just give an highlight about lightning forecast and warning. So I got a project from ISRO and NICE. We are working how to increase this, the accuracy, and we can go, means we are trying to do research month-wise also, because the lightning activity in a month of March is quite different from April, and it is also quite different from May, and the death pattern is different, the triggering factors are different. So we are trying to understand, and we are trying to train the machine so that we can have accurate forecasting. But still, These are the application softwares which are available. The best one is Damini, which can give you 7 minute, 14 minute, 21 minute before. So that this is based on the observation LIS, the instrument which is being IIT in Pune is handling. So it can give you 20-kilometer radius live track also. There is also rain alarm apps are there, Umang, Mausham, Meghdut. So you can get it from 3 hours. There is also another network, Indian Lightning Network, IILDN. So there is another which is handled by University of Tripura. So if you type in the Google, you can get idea where the lightning activity is happening in Odisha or India. You can get an idea on that interactive mode also. This is our Meghdut and Mausham app. Meghdut is basically for farmer, so there is an auto notification. And also right now you must be like in Bhubaneswar or in many places there is a common alert protocol which is given by SRC. A message is being pushed, but sometimes if you check, it happens after the lightning activity happened, we get the message. So that is why the accuracy, the priority, and everything has to be developed. This is what we have published a paper, and if you can see, as I was talking about, if there is more lightning activity, so that doesn't mean more death will happen, because it's not directly correlated. It's almost like if you are exposing yourself, then death happens. What I can say you, just I am giving you example like West Bengal and Odisha. West Bengal has half death as compared to Odisha, because the peak activity in West Bengal happens at the night, but the peak activity in Odisha happens, in the working hour. So that's the reason why more death is happening. So it is all about your exposure in the unsafe areas. And if you can see, this is a day where 11 death has happened. You can see this is the forecasting by IMD, and this is the data which we have taken from NRSC Hyderabad, that is LIS data. This is CG data, cloud to ground. You see, there are 27,000 CGs, but still the death is few. So that doesn't mean every CG killed people. So it's all like if you are at the suitable location, so obviously they will try to connect, because the electron will try to connect and they will give you the current in return and you will die. So that is the reason. So we have to understand these things. Then only we can plan, and we can go for last mile connectivity. So that is why this is the protection and safety. There are a lot of lightning arrestor, lightning conductors are coming up. Still, you require an expert. If you are installing these arrestor, maybe for your high-end instruments, maybe in your home. So if it is a semi-Faraday case, you don't require anything. I believe, because the arrestors which are being sold in the market, because we don't have high voltage lab in India, so there is no testing centers. Still, these many organizations are trying to develop, but we get it from outside. So many are not being tested. So that is why you have to take idea from the the experts before installing this. Also, lightning conductor. Many of these PWD buildings, like this is one which I am showing in case of our university. You can see this is a conductor. This is just a Franklin rod. A rod, then you have a copper wire. This is for direct strikes. And if you can see, all these are not at the highest point. The tree are at the more height. Obviously, what will happen is the tree will be connected, not these iron rods. So the use of this conductor is to capture this electron and discharge it, because this copper wire has been earthened 5 meter below, something like that, and so that is why there will be no resistance. The reason is very simple, but the problem is somebody who has done it has just copy paste from the internet, but he didn't understand which is the highest point where it should be put. So that is the reason it is of no use. So that is why whenever you put something in this building, but this particular building doesn't require Franklin rod because it's a semiconductor. And all these unsafe houses you require, either it's a kacha house, asbestos house, where you don't have metallic cover, then if it is not a semi-Faraday case, then only you require this kind of things. Then there is another thing which is coming up, like can palm tree save lives from lightning? Possibility and failure. So what science says, like palm tree is like another tree. Okay. So they don't guarantee human safety. So it will also, same thing will happen. Only thing, if you see what our ancients were doing, they put palm tree not in front of the home. They put it in the agricultural land, but it is a highly elevated land. So then only what will happen, sometimes when these charge particle will be coming up, so it will be connecting with the palm tree and nobody is going to stand below palm tree. So then there is a chance it will not go to the water. So it cannot be solution. Again, there are a lot of policies coming up. 10 tree, 4 trees are burned. So palm trees are the tree where, lightning easily connect. And again, once it is burned, so it will not play on, like a conductor next time. So if we plant palm tree right now, it will take 16 years to become a high spot at that region, or become a, some structures which can, means whatever science they are saying. If I go with their, discourses, I find that after 16 years it can play a role, but most around the world it failed. So that is why palm tree, means planting palm tree is not bad, but saying that palm tree will save life, I don't think so, because what is our observation in Baleshwar, it negates whatever science, because there is no scientific paper, nothing is like that. Then these are do's and don'ts. I am just going for the solution. So the solution is, like I just said, there are 3 things which we can look into. That is called a sthana, or a place. Then kala, what is the time, and then we have to talk about what is the action. The very simple is, whenever you are seeing lightning, or whenever you see a black clouds which is stretching up and down, okay, or whenever you see, the mostly majority of the times it will be CC. Then after 15 minutes, then it can, translate into CG. So almost 30 to 45 minutes you have. So what you have to do, you have to go inside a semi-Faraday cage house. So till you see there is a last lightning activity, 30 minutes, there is no activity. That means the convection process has stopped. So again, what we have done, we from our whatever research we have done inside the field, identifying the pattern of deaths. So what we try to understand, we can identify which is a safe area, which is an unsafe area. The 99% safest area is a semi-Faraday cage house. Apart from that, whatever place you are, so there is a risk. So it increases 5 to 95%. But most of the death which we are seeing, if you are standing below tree, if it is a pre-monsoon, if you are moving in an open field, then if you are inside water, so there is a chance. If you are close to the metallic conductor, or a combination of these things also. Sometimes what happen in Moirvans, like 3 farmers, so they finish their work and they are taking bath in a pond. So there is a huge tree close to the pond. So the lightning strike the pond, through the ground it comes to the water, and all 3 people are. So that is why you can see here, like do's and don'ts. Like most of the times, what the Odisha Disaster Management Authority or Government of India is doing, they are putting a do's and don'ts. But these do's and don'ts should be a targeted one. You shouldn't make the people understand. So this squat position, this cannot save you life if it is a high intensity lightning activity. This is the only, means the last option which is available. So that is why, unless we work in such a way that whenever lightning activity is happening, so the unsafe areas, people should not be there. Very simple thing which we have to do. So first is like safe and unsafe area. So we can easily identify inside a village which is a safe area, which is an unsafe area. Then I am talking about the time. So we have used, I think I have not shown, we have done some analysis of the time of lightning activity. So 85% of the activity happens after 12 o'clock, mostly in the second half, and it continues till 12 o'clock night. But the death happens between 2 to 7. Means what I'm trying to see, the peak of this activity happens at 2 o'clock, and it sometimes it continues to 7 o'clock. So that is why almost, if you see, 80% death happens during this time period. And this is the time period. Again, if I go a little bit down, if I see who are the people killed, and if you see in monsoon, almost 65% death happen in monsoon, and majority are the farmers. And then what we try to do some work in Balasore, like we try to see there we try to develop a lightning calendar or lightning risk advisor. Then we try to merge with the farming calendar. And if you see the farming activity, so in month of August, majority of death happened. And this is maybe due to the climate change also. Like you see the farming activities, previously it was 180 days, then it reduced to 120 days, right now 90 days. And it all depends on the onset of monsoon. So the farmer require water to prepare, means inside the agriculture to prepare for seeding or maybe sowing kind of activity. So this is the most vulnerable time. If I look into the pattern of activity the farmer does and the time period and where he is killed, we just put for valuation, and we created a probable risk map. And then what we are advising that there are some days which are safe, completely safe, where no lightning activity is happening. There are some days where there is a caution has to be taken. You have to, before going to the field, you either look into the means whatever conditions are created. Because in case of monsoon, the weather conditions are more static. So the forecasting is a little bit goes to 70 to 80%. So they can look into IMD forecasting or any other forecasting. Even if the farmer also can look into, so like if there is something like moisture is in the atmosphere. Okay, so then in the morning you can look into that. Sometimes you can look into nature, and you can also make your own prediction. So what will happen in the second half? So what we are trying to say to the farmer, so the best safest time to work is like 5:30 to 12. You finish your work. Do not expose yourself in the second half. You are completely safe. Even if it is a whatever house it is, because 10% of death happens in kacha house, and in case of asbestos or brick house there is injury, no deaths. So that is why even if you go with whatever house it is, so there is a chance of direct strike is less. Whatever there is a chance of lateral strike. So if you are not in the agricultural field, not inside the water, so there is a chance that so you are not exposing yourself. Again, whenever I make a presentation before the the bureaucrats or the government, they said, what about the economic loss from 2 o'clock to this time? What we are trying to say, there are 8 to 10 days of a month, so where these high intensity activities happen. Again, what we are saying, again we have to look into the monsoon also. If you see whatever changes is happening, there is active monsoon, then wet period, dry period. So right now, what is happening? If you ask me, like, what is the impact of climate change in the monsoon? So that is, if you see the total amount of rainfall, it has not changed. Like 10%, that is called as normal. But what changes has happened? Small time period, more rainfall is happening. But more, time, there is a dry period. So in between the wet period and dry period, more number of monsoon breaks are happening. This is the time in the last day or the fast day, so you have more lightning activity. Even if I can say, like in the morning also, we are trying to develop some forecasting models. So the convective initiation, like we are trying to play with the machine learning, that maybe 6 hours before, so what are the parameters so which triggers lightning activity in a particular region. So we are trying to do means we are trying to classify the different zones, the triggering factors for every 15 days, and then we are looking into what are the triggering factors, which are the very simple initiation activity or the initiation which is triggering the lightning activity. But still, this is a very complex process. We are on the way, but the very simple way where we can reduce the death is very simple, like Stana. If we identify inside a village which place is safe, which place is unsafe. Then time, as I said, the time of death is 2 to 7, most of the deaths. Then what is the action? So to remain inside your room during the lightning activity. So that is the simple way. Whatever we means, if you see the government approach, so they put more money into forecast, less money into the lightning, and in that case also, in case of forecasting, so point forecasting is almost impossible. And again, once you do forecasting, the people has to build a trust, and that they have to believe you, and they don't go outside. So there are many things which has to be done. And we are trying to do a lot of community engagement in North Odisha, means like villages, colleges, even in block level offices. We means 200 to 250 awareness campaigns our university has done. And this is a very interesting thing which happened in Bihar. And in case of Bihar, 448% increase in death is happening. In single day, 100 people die, 111 people. This is one activity which happened, which we have published this paper in Natural Hazard Journal. And you can see there are two parameters which, that is called as CAPE and CI, convective available potential energy, convective inhibitor. It's like a pressure cooker. From the down we are heating, and in the top we have a nozzle. So in the down, when you were heating, energy is created, that is called convective available potential energy. If there is more energy, it will move more up. So it moves more, up. So what will happen? More high intensity activity happen. So that is why Doppler radar used to, refractive index. Then there is a CI, which naturally it will push down. It will not allow to move up. So when it becomes weak, so then what will happen? So it will move up, and this is the same thing happened. So this CAPE and CIN value increase like anything. And if you see how this CAPE and CIN are observed, maybe in Odisha, I can give an example. 3 places like Bhubaneswar, Jharsuguda, and Gopalpur. These are the 3 places where they've sent a balloon. And per month, for a week means 4 days for a month, these data are created, and then these data are put into the reanalysis model. And whatever KFCIN value we get, that is that doesn't represent the whole time period or whole season also. So that is why the model fails. So that is why a lot of research is going on, but still this CAPE and CIN are very critical value. I mean, if we can observe these parameters, that can be a triggering parameters for forecasting also. So what we have highlighted in case of Bihar, even if you see in Bihar this year only pre-monsoon, there are a lot of death has happened in Bihar and UP. And then this is all about lightning. Then we talk about heat wave frequency. We have done some kind of research on heat waves also from 1955 IMD data. What we see, as I have already shown, that heat frequency has intensified and it has spatially extended. Most heat waves, you must be knowing, April to June. So northwest districts suffer most extreme heat. So a lot of government initiatives are being taken up. Still, there are long-term impacts. Apart from death, there will be long-term impact which government has to think of, like adaptation priorities, like specifically agriculture, water crisis, groundwater crisis. So a lot of things is going to happen. And this is one about forest fire. So one paper we have published in Science of Total Environment. So you can see the trend of forest fire is increasing in Odisha. It's not about, Similpal only. So there are a lot of places it's increasing. And we found that it is also sometimes naturally induced, because the time period, the month of February, March, sometimes April, so there is less moisture in the atmosphere. It's becoming more dry, what we found. And we tried to how to, there are a lot of managements which are done around the world. So we have put it in that way. That paper we have highlighted, means we can easily reduce, and still government is working on that. A lot of monitoring is being done, but still it's increasing. And the Onugul is having the highest forest fires. And this is about the coastal erosion. This was my PhD work, which we have done. Means this was my core area of research. while I am doing my PhD, means how the coast is behaving, to the climate change or whatever anthropogenic changes is happening. What I find, so there are a lot of, Odisha is a prograditional coast, but right now there are a lot of hotspot of erosion. Many villages are inside the sea. If I see, the Odisha coast, the triggering factors, because in Odisha coast there is a collision between four forces. One is fluvial, which is bringing sediment and water to the sea. Then we have sea forces like wave, tide, current. Then okay. Then we have these meteorological forces or extreme events. They again we have anthropogenic forces. What we are seeing right now means our coast naturally has a resilience to the changes which is happening. If you see what we have found, that if there is a cyclone like super cyclone 99, so almost all the coast were eroded. But after 5 years, again the deposition happened. So there was a phase of erosion, phase of deposition. But the only issue which has happened, like due to the construction of dam and embankments, there is a exponential reduction in sediment and water volume. Obviously, if you see the major changes which has happened at the estuary or the river mouths. And again, the second thing which has happened, that is the construction of ports. And mostly, if you see, there are three ports. We have published another paper on the ports also, how the port is playing a role. If you see Paradip port, and there are two berths. So obviously, what is happening? If you see, due to the wave breaker, so there is a erosion in northern side of the ports, but there is a deposition in southern side. If you go to the north side of Paradip, it's almost eroded. And once we construct the hard, engineering infrastructure, seawall kind of thing, so it's shifted to, Satbari. Again, there are a lot of changes which has happened to, Gahirmatha also. We have already, documented this thing in different research papers. And if you go to this Gopalpur port, so if you see the northern side is eroded, but what they do, they put soft engineer. They bring the sand from the southern side and put it in the northern side. So still the beach is there, but it is eroded. But if I go to the Dhamra port, which is a natural port, so there is no erosion. Maybe the parameters are different. So that is why whenever we talk about tapping these resources or constructing any ports, so be careful. What is the chains of nature? So how the process is working. So we cannot go against the nature. If you go, then it will move to another system. So without understanding this thing, if we go for any structures in the coast, so what will happen if you go against them? So all these engineering structure cannot stand because these are huge process. So that is the reason we have to really think scientifically before talking about tapping the blue economy and all these things, because there are a lot of ecologically sensitive zones out there. So they will be completely affected. If you see, Odisha coast is full of ecological sensitive zones like Gahirmatha, Chilika. Then we have horseshoe crabs. So many things are there. Many biodiversities are there. It will be affected. So coming about this, there is another work we have done on sea level rise in Odisha. So most of the times when coastal erosion happened, so people say it is sea level erosion. So it is happening, but it is happening in a very slow pace. So that we modeled, so how the means IPCC sea level rise. So what are the areas which will be affected? But we are finding some kind of sea level changes close to Kendrapada. We just try to do it, from era 5 kind of analysis, but still more research has to be done. Then another thing which is very critical, that the groundwater decline, seawater intrusion, reach to water scarcity. There is a paper which has come off globally by a group from America. They said that coastal waters are disappearing around the world, not in Odisha, but around the world. That's the reason we try to, uh, do some work. I think this is the work we did with the groundwater board of Odisha. This is a paper is on way. Still, we are working on that. We are trying to means which are the vulnerable area due to the saltwater intrusion. So if you see the trend of groundwater decreasing almost everywhere. Maybe that is anthropogenic. So that the monsoon is changing, like a small period, more rain, longer period, dry period. Then we have to just think of how to recharge this groundwater. So what will be the utilization? So some kind of critical mapping has to be done, and there are a lot of ways you can reduce this salinity. So government has to think of. We have just started this research, and then another thing what we try to do, we tried to work with ecological sensitive zones. I have paper in Science of Total Environment on Chilika Lake, also Rusikulya, Gahir Mata also. We try to deliberately turtles how they are changing their places from Gahir Mata to Rusikulya. Again, if you see, majority of the these olibrille turtles are now doing their mass nesting in Wheeler. So they understand the ecophysical condition better than scientists also. So that is why we try to do some kind of analysis. But another thing which we have done, that is the human wildlife conflict due to climate change. That is in Bhitarkanika. This is a paper which we have submitted. Almost 37 deaths has happened, and this is what we call as over conservation. Sometimes what happens as a scientist, so what we do, whatever animals we have access or data is access, we do a lot of research on that. So many of the species we don't have access, we don't do anything about them. But in case of crocodiles, so what exactly has happened, this Bhitarkanika carrying capacity is like 1700. So if it goes to 2500, what will happen? So obviously it will go to the rivers and they will attack humans. It's all about food. So that is why threshold has to be defined, and it's not like one way you go for conservation and all these things. So if there is a bigger number, so you don't require artificial kind of things. And in case of horseshoe crabs also, we have done some paper on that also. If you see, these are the creature which is there from 3 million years, because they are adopted half of the time in water, half of the time in land. Their egg pattern is quite different, but still we are doing artificial breeding, and government of our, this is like something which we put money to show the whole world we are caring about horseshoe crab. But these animals doesn't require, because nature has given them their way, they can survive whatever condition it is. But as a scientist, we don't require to highlight means the over consumption conservation kind of things. And this is another paper which we have submitted. What will be the climate change impact across agroclimatic zones of Odisha? As I said, like declining rainfall in plateau region, then coastal zone, there is a erratic rainfall, cyclone risk, rising heat temperature extremes, soil moisture decline since 2018, rainfall and water decoupling, water scarcity kind of things. So what we try to do, future climate projection will be 1.5 degree centigrade to 2.2 degree centigrade, whatever the global, discussions is going. So we should be below 1.5 or 2 degree. But our scenario showing we will be moving, above that. So more droughts and floods, increased, agricultural vulnerability. So that is why right now the agriculture ministry or the government of Odisha has to think seriously about this climate resilient crops, soil moisture conservation. We have to really think in the nature or whatever, like organic farming or natural farming. These are the ways we have to really start. Because we have surpluses, we have to think about that, and we have to prepare ourselves from today only. If we don't prepare, so there will be lot of impacts which will be coming up in future. And this is another paper which one my PhD scholar has done, climate stress and paddy productivity in Odisha. They try to correlate. that rainfall variability, the dry day frequency strongly reduce the yield. If there is more dry day, obviously the yield will be reduced. Then another thing they find that warm night temperature, if it critical threshold goes over 28.7 degree, it will decline rapidly for the paddy. And we have seen, you see, climate-driven yield anomaly is 50%. Okay. Drought year yield losses, coastal plain is 2 to 4%, but interior plateau it is 9 to 10%. And average yield is 27, quintal per hectare. But interior region, so you can say 60%, coastal region is a little bit stable, less than 50%. So moisture persistence, dry days is the strongest climate driver. Warm night extremes causes non-linear yield decline. Interior rainfilled region face highest climate risk. Climate sensitive has increased since mid 2010. So paddy productivity in Odisha is increasingly controlled by compound climate stress, especially dry spells and warm nights. And this is the disaster risk escalation by 2036 and 47. So rising risks are there. So whatever research we are doing, so like it's not like me, because we have a lot of collaborations with agriculture department, maybe NIT Rourkela. There are many people outside India also. Like it's a lot of efforts from many people. I'm just presenting on behalf of them, and many of our scholars also, they are doing a lot of hard work. What is try to say, increasing trend observed. So 2036 highest frequency, stronger intensity, much higher frequency, severe intensity. So the condition like heat waves, lightnings, floods, cyclones, forest fires, so it will be increasing. Risk will not just increase, they will accelerate. So steeper rise in hazard frequency, intensifying impact on life and livelihood. So greater stress on infrastructure and economy. Urgent action today for a safer, resilient Odisha tomorrow. And again, another thing, what do I try to say, like how to travel, because there is a declining supply, resource and ecosystem service. There is an increasing demand. So, margin for action is narrowing down. So that is why future generation has to really think of a lot of innovations, a lot of technology also. But still, what I say, you have to understand the nature. So if you don't understand the nature, that's called as geo-designing. It's more critical. We have to really think of sustainability, sustainable demand and sustainable supply. So it's not like erratic exploitation. So if you do, because we don't have so much of opportunity to do that, because the funnel has reduced. So that is why when you talk about future, so you have to talk about sustainable supply and sustainable demand. Then next thing is district hotspot for future risk, because coastal Odisha, western Odisha, north Odisha, so they have a different pattern of disaster, and we have to really understand that. And this multi-hazard convergence mapping has not been done in Odisha, but still we are planning to do. So the compound hazard kind of thing. These climate risks are not isolated; they overlap, interact, and intensify vulnerability across the districts. And then there will be sectoral impact. Every ministry has to think of. It's not about Odisha Disaster Management Authority, agriculture, water security, then public health, coastal livelihood, infrastructure, forest ecosystem, because we have to really think about climate resilient infrastructures. So that we have to just think of. So there are many other issues are also there. Then preparedness solution, act early, plan ahead, stay resilient. So what is he saying? Already the government of Odisha is planning for heat action plans, but still we are not very good in lightning, reducing death. But the very simple way we can reduce, if we can reduce the exposure of the targeted populations who are killed, like farmer, grazers, laborers, and these are the people who has to be out, and they may asked not to be outside during the lightning activity. Then flood forecasting, still a lot of research are being done, but still more can be done using machine learning. Cyclone, we are able to reduce the human death, and the government is claiming they are also reducing the cattle and wild animal death, but still economic damage is increasing. If you see, the damage is not decreasing. So obviously we have to think of long-term plans if you want to reduce the damage. Then forest fire alerts, a lot of research is being done, but government is doing many using many monitoring platforms. They are acting, but still many things has to be done. Then district climate advisories. What I think they have a district disaster programming officer. What I believe that every block should have some climate advisories, because each block is different from other blocks. So, but at macro level, some kind of planning has to be done. I have written district climate advisory. It can goes to the block level, Then policy roadmap to 2036-47, policy needs like climate resilient infrastructure. Then again here, when we talk about climate resilient infrastructure, I believe that we have enough indigenous knowledge also, like the architecture of Konark or Puri temple can be used. Many things, many buildings which are there, or many kind of resilient infrastructure can be developed from Odisha's wisdom. Then seasonal risk calendar integration. So a lot of scientific calendars has to be developed, and every ministry has to get a plan for it. Then district to come block level adaptation plan. Again, AI based forecasting. Because most of the times whenever you see AI based forecasting, so simply used some kind of artificial intelligence or algorithm. Some big organization come up and make a presentation. They then don't talk about accuracy, or you can say the utility of that particular piece of information. Because if it is not accurate, so it will of no use when it is life and death like condition. Then we have to talk about ecosystem restoration, community resilience financing. Then 2026, this is the foundation. I think then 2036 transformation, 2047 resilience leadership. We should work in that way. I believe like a lot of technology will be coming up, but still the researcher in Odisha has to really play a critical role. What I think, like somebody who comes from Delhi or maybe, so they didn't understand what is happening at the local region. Because whenever you see any disaster, it's a more localized events. If I see lightning, it's a very localized. So its impacts are different. So somebody who works at Fakir University can give better idea than somebody who makes a review meeting maybe at NDA. Because whenever you discuss in NDMA, it will be more on mitigation, more on forecasting. When I see at the ground, it is of no use. Because it's of no use, it doesn't mean we should not do research. We should do research, but that cannot save life. So that is why the universities, state public universities, colleges, or the organizations like Society of Geoscientists, so they have to really play a very critical role. Understanding all these issues or the uncertainties, and can means come up with some kind of publications or some kind of advisories maybe to the government. So building a climate resilient Odisha, plan today, prepare now, protect tomorrow. So that is the need of time. And so whatever research what we have done means what I see, the people at the last mile, or the people are maybe in the very inaccessible area. So they need our help. If you see hailstone, or you see tornadoes, small villages all are desperate. So they need our help, and we have to play a critical role. So that usually bring passion inside me to think differently, work with this technology, whatever data is available, and collaborate with many national and international organizations. Usually, we have a collaboration with IMD, IITM Pune, ISRO, NRSC, NIDM. Apart from that, I have also collaboration in South Asia, Southeast Asia. If you see my publication, a lot of foreign collaborators are there. So obviously, this is all about learning, relearning, and bring something something different, in your publications, which is being translated to the last mile society. So thank you very much. So if anybody has any query, I don't know how much I am able to convince about my research. This is a small presentation from myself.
Thank you, a big thank you, Professor Mishra. We are really benefited by your exhaustive talk on. I was thinking that you will be only limiting yourself to lightning and its forecasting and all, but you have covered both anthropogenic as well as the natural calamities which our people are facing, especially our society is facing. There are not very large number of questions. Our president, Abhi Panigraisat, is asking some questions, very small questions he has. So I will request now Panigraisat to directly interact. Sir, unmute करूँ sir.
Okay. Thank you, Professor Mishra. It was a very informative presentation, and I think everybody will gain from whatever you have said. I have two, three things which requires your kind knowledge to throw upon. So one is very, very simple as we are normal human beings. While driving, if we have a rain and lightning, should you drive the car or not? Even if it is a closed car. I saw one of your presentation in which in the slide, the open cars are not advisable. If it is a closed car, how safe it is?
So whenever it's a closed car, which is totally metallic cover, without this rooftop and all these things, so it's completely safe. If you drive or if you stop, it doesn't matter.
Doesn't.
But if you should not, you should be inside. You should not touch outside.
Okay, okay, okay. That is safe enough. Number one. And number two, you see, we are facing difficulty in earthing. Because earthing is one of the very important uh, matter for diverting the electricity to ground, earthing. So, and I think in most of the places we are seeing that people are not aware how to make proper earthing. Is there any organization which deals with this proper earthing and a two-story, three-story building earthing and a high-rise building? We have seen lightning arresters, but we do not know whether they are effective or not.
Yeah.
So, is there any method or is there any organization which deals with this earthing?
Yeah, so there are some global experts who work on this earthing and arrested. They are called as Cape Electrical, based in Chennai. There are very few researchers, but whenever you talk about earthing, it's a separate thing because the building is naturally, what is happening naturally. Something is you are putting the rod, which are means act like a earthing. You don't require a separate. You can put it for your electrical appliances. In urban area, most of the time electrical appliances are burned. For that, you require earthing. But for the building or the huge amount of current, so if it is a semi-Faraday cage, what I am trying to say, when roof is metallic cover, pillar is metallic cover, at the foundation you go 8 to 9 meters down in the foundation. Obviously, the electron will be captured and naturally they will be discharged down.
Okay.
But so if you want to take advice for the arresters or the earthing, I can give you and he will help you. I can give a number which known as Dr. Gopakumar. He is from Cape Electrics, and if you Google his name, so there is a group who work with this low cost mitigation. Means what I'm saying, they are working like how to make a low cost houses inside the farmland. So if any farmer is doing, they can go inside there. So they were working on that. So you can take advice from them.
Okay. I have two more questions. Two more. First one is when we were children, say 60 years back, the temperature of Bhubaneswar was never rising beyond 33, 34 degrees centigrade. Long back. And now the temperature has risen. In 1999, it went up to 46.7 or something like that, the highest temperature which has gone. Whereas under similar circumstances, in let us say the western coast of India or other cities of the country on coastal side, the temperature has not risen so much. What is the reason why Bhubaneswar or the nearby coastal area has been affected much higher than that of the comparative other similar situation in the other parts of the country?
Yeah, so when you see that is called as if you see the cities specifically, that's mostly called as land surface temperature. If you use LST, you can see in Bhubaneswar also there is a 2 to 3 degree temperature difference. That's called as urban heat island. So if I see mostly in the urban area, it is mostly concretization. Means the reflection of the heat from the concrete that increases. Another thing, if you see that the use of lot of ACs also, that increases the outside temperature. But if you see overally, there is an increase in temperature, but it's not linear, it's non-linear. So there are a lot of regional phenomena, local phenomena which is happening. And if you see, means what is my observation, what I see, like there is a lot of degradation of forest lands. Obviously, there is open spaces are there, means rock spaces, concretizations. So that is the only reason of increase in temperature.
Okay. As the last question, uh, uh, we are also prone to earthquake, but not that much because we have also felt the tremors in Bhubaneswar, say about 10 years, 15 years back. So how, and if I remember correctly, I think our Mahanadi lineament is also earthquake prone. What is the status of so far as earthquake disaster is concerned?
Uh, Means whatever scientific assessment has been done by Government of India, so we don't fall into major vulnerable zones like 1 to 5. We don't fall, but
Okay.
that also changes from time to time. Uh, so this is a very slow process. But what I think, like apart from Mahanadi, there is a chance that in Bay of Bengal, we see there are some symbols of these earthquakes. I mean, maybe the subsidence of sediments. Sometimes I think some 10 years before, which has happened inside the Bay of Bengal. I mean 6.9 or something like that. So there are a lot of changes which is happening inside the sea. Very few research has been undertaken. But in case of Mahanadi, I don't find it can trigger a major earthquake.
Okay.
Uh, that may be. But still
Okay.
more research has to be done.
Right. Thank you, Dr. Mishra.
Thank
Thank you,
you,
Dr. Mohan.
Professor Panigre. Thank you, Professor Mishra. Thank you, and Panigre sir also. And our host, Jadavanda sir, secretary. Is there anything to speak, sir?
No, Professor K.C. Sahu wants to say something. Yes.
Professor Sahu from IIT Bombay. Yes, sir. Sahu sir.
Sir, please unmute, sir.
Please unmute yourself, sir.
Sir, please unmute.
Sir, unmute କରନ୍ତୁ sir. Sir, unmute କରନ୍ତୁ. Mute ହେଇଛି sir.
Speaker on କରନ୍ତୁ.
ହଉନି. Now it is done.
Can you hear me?
Yes,
Yeah,
sir.
yes, sir.
Hello.
Yes, sir.
Yeah. Good evening to all of you. I mean, I congratulate Professor Mishra that the way he has spoken, the amount of material he has told us. First of all, I thought he will be talking about the global warming and the climatic changes. But I found, as a real scientist, he has spoken of a new problem of global warming or climatic changes. That is the lightning. Lightning is something new, and it's necessary that our scientists must look into it. The impact of global warming or changes of temperature, changes of moistures, and the circulation of moistures, which brings into the tragedy of lightning into the people. It's very necessary that work should be, even laboratory work should be done to look into what to do to avoid such lightning for the layman or the people who will be in the field. We are trying to avoid lightning by putting lightning conductor, but that doesn't solve everything. We must look into the people who will be working in the field and how to protect them, and proper instructions should be given. In that case, Professor Mishra's investigation and work seems to be very appropriate, very useful to the nation, and I wish him all the success in that region.
Sir.
Most important thing is that Professor Mishra has tried to touch many interesting things, many problems of Odisha. Some of the problems requires deep investigations and interaction between administrations and scientists. As a matter of fact, when we are seized with the coastal problem of Odisha, I am really afraid to see the coastal road now being made along the Odisha coast. As such, all our transportation lines, railways, roads, and other things are in skew to the natural drainage. And once we are against the natural drainage, all our construction like roads, railways, embankment, then problem comes of discharging the sediments, discharging the water, then flood and other thing comes. In the meantime, with the global warming coming up, and you must be hearing about the super El Nino, God knows what it is going to do. We will be having drought, flood, heavy rainfall, and cyclone, and Odisha being in a very sensitive point, which Dr. Mishra knows very well, we are highly vulnerable to it. One thing makes me afraid. If we are going to have large amount of rainfall, what will happen to the Hirakud Dam, which every time, whenever there is a flood, heavy rainfall, we are all shaken together. What will happen in the coastal regions in case there is failure? Suppose with the super El Nino coming in case you have got heavy rainfall, what will happen to the dam and what will happen to any disaster coming in? These are some of the things we have to understand. I saw a wonderful picture of this coastal road now being developed in Odisha. Beautiful picture. I've seen lot of roads, lot of traffic going on, lot of materials going through it. And we have got a beautiful seashore developed. But once you have a coastal road running across the discharge channel of all the sediments and all the water which is coming in, the sustainability is doubtful. I was just thinking, what will happen to a native Oriya who wants to visit to the seashore from his village? If there is such a large road in front of him, mega highways with a lot of traffic going on, he cannot go to the seashore. He cannot go into the seashore anytime. That means development for which, if the local people suffer of it. We have seen that the CRGR rules which act which has been made, we are not supposed to develop the coastal zone. We are supposed to develop the people and the living standards of the coastal zone people. But when you have a large roads running along the coastal road, the roads are not for the people of Odisha. It is for the people who travel from Calcutta to Madras, or materials which travel from Calcutta to Madras. Therefore, when you break the rules of coastal zone, it is the local people they suffer. It's very essential that our scientists must convince government regarding the development of variety of coastal development they are undertaking. For example, one thing, many of the typhoons, the Phylline, the other cyclones which approaches Odisha breaks down and dozens crosses because of the hill ranges that we have got highland like Similipal to Koraput. These high ranges, if we destroy them, if we destroy, destroy them or deforest them, all the cyclones which is supposed to pass through Odisha coast will not be decimated by the islands. Therefore, it is very necessary to keep our hill ranges in the middle part of Odisha, like Koraput to Simlipal, intact without damage. However, the modern development shows the other way. With all this development work which is going on, which goes against the nature, it is high time that we learn from the nature. We build our things inconformable to nature. And here, scientists like Mr. should come up and show that be with the nature, don't destroy the nature, don't do the deforestation. See that don't stop the flow of water by big dams. Any disaster comes, our future generation will suffer. We will be able to build it up. We will develop so-called, we will have our expertise and build up large structures, but the impact of which will be felt by the future generation. That's the only way our modern scientists can do it. And I'm sure Professor Mishra's work is very, very interesting and significant, which our developer planners they should realize. I'm really enlightened by Professor Mishra's
Thank you.
lecture. Thank you, all of you.
Thank
Thank
you,
you, sir.
sir.
We are almost come to the end of this thing, and before that, I will have a request to Professor Mishra that you know that we in AGAT we actually publish a biannual a journal in which simulate the type of the type of research you conduct and carry out. It actually fits to the in the type of the journal we are publishing. So I request that either you or your research scholars should contribute some articles sometimes. And our June volume is coming up very soon. Almost it is in the printing stage. Then it will be coming in December. So in December issue, we will be awaiting your article, and that will be welcome. Thank you, Professor Mishra. Before that, Jadananda sir, our secretary.
No, before that, anybody else has to say anything or any question?
I am not seeing anything on the chat box.
Okay.
Only thing is that Dr. Jamana Singh, he has congratulated Professor Mishra, excellent talk, and that is from Professor Dr. Jamana Singh.
Okay. Now, I'll also, before we close this session, I would request our President, Sri Alok Bihari Panigrahi, would you like to have some last comment or say something? Unmute, sir, unmute.
Yes. After the presentation and the further enlightening by Professor Sahu, I think Odisha government actually after this 1919 super cyclone, if you remember, anybody, those who are present in Bhubaneswar, so we did not have any disaster management infrastructure. Just after the cyclone, there was nothing, if I remember correctly. There was one satellite phone available with the Chief Minister. The then Chief Minister was Giridhara Gomango, and only one satellite phone was available. The rest, entire state was cut off. But see the preparedness which the state government did in a period of time. And when Fani came, absolutely, those of you have seen, the cyclone is over. Next day morning, we could take a morning walk. So the preparedness, so far as the disaster management is concerned, cyclone management is concerned, was of highly excellent standard, and it was appreciated by entire world, including the United Nations, where Odisha presented how to make this disaster preparedness, post-disaster preparedness, and pre also, both pre and post. And Odisha being a leader, I think we are facing difficulties in, as we have seen, lightning is one of the area. The Kala Baisakhi is another area we are finding. After Kala Baisakhi, what happens? The power goes off. So, and many times even where I am staying, 3 hours, 4 hours of power is definitely not available. And they say some jumper has gone out or whatever it is. So what we require is a very strong forecasting mechanism and sensitizing the people how to deal with this disasters. That is my final observation. And we are very thankful in SDT for a very simple and excellent presentation. The presentation was very simple, but of very high standards. Thank you very much, Professor Mishra.
Yes, yes.
Thank you,
No,
sir.
so thank you very much, Panigrai sir. It's a wonderful deliberation. I think we must profusely thank to Professor Manoranjan Mishra for his excellent and very, very effective talk. And thank you very much for accepting our invitation and presenting your vast research findings and research work. And we hope that you continue to do that. And as our Dr. Mohanty said, please contribute to our journal. Our Farooq Saab there, who is our editor. And I thank each and every one for attending this seminar. And I wish that everyone should have a nice outing like as our Vice President Tilochan Montsar is having, with beautiful sea beach and the
Yes, yes.
windy trees. So I hope everybody is same environment. Thank you all for
Thank you.
attending this seminar,
Thank
and
you.
good night. Thank you.
Good night.
Good night.
Good night. Thank you, sir.
Thank you, Mr. Thank you. Thank you
Thank you,
for
sir.
Thank you. Thank you.
accepting our proposal. It will be a nice association. We'll be linking you actually in many respects. Okay, thank you.
Okay. Thank you, sir. Good night, everyone.